China builds, the entire planet notices. Every project outdoes the last, bigger, faster, and bolder than anyone else would dare. From a port run entirely by robots to an underwater highway that never sleeps, every new project breaks another record. And when you see how far they've taken it, you'll understand why America feels stuck 100 years in the past. Number 8. Hong Kong-Zhuhai Macau Bridge. It looks delicate from a distance, a silver ribbon stretching across blue water. But the Hong Kong-Zhuhai Macau Bridge is one of the boldest pieces of engineering on Earth.
Another milestone will be reached in the world's longest sea construction project, the Hong Kong-Zhuhai Macau Bridge. The final segment of its undersea tunnel is finally being installed.
It's not just a bridge, it's a bridge, a tunnel, and a pair of man-made islands all working together as one. The entire link runs about 34 miles from end to end, making it the longest sea crossing of its kind anywhere in the world. What used to take hours by ferry or a long highway detour is now a smooth drive that connects 3 major cities in less than an hour. To make that happen, builders had to fight the ocean itself. Out in the middle of the Pearl River Delta, where waves, tides, and typhoons constantly clash, they created 2 artificial islands. Think of them as man-made stepping stones for cars, one where the bridge dives under the sea, and another where it rises back up again. To form each island, workers drove more than 100 giant steel cylinders deep into the seabed. Each cylinder was then filled with rock and sand until it became solid enough to hold roads, tunnels, and buildings. Doing that in calm water would already be tough. Doing it in rough seas where the wind can change by the minute meant holding steady while the ocean tried to knock everything off balance. Between those islands runs the most dramatic part of the entire project, an undersea tunnel about 4 1/5 miles long. It was built piece by piece, like a massive underwater jigsaw puzzle. Each tunnel section was made on land, sealed at both ends, and floated out to sea like a barge. Every one of these concrete giants was about 590 feet long, 125 feet wide, and 37 feet tall, and each weighed close to 80,000 tons. Once in position, the sections were slowly sunk into a trench on the seabed and locked together with watertight gaskets, all while divers and surveyors checked the alignment inch by inch. Picture nudging massive concrete train cars into place underwater until the road inside lines up perfectly, and doing that again and again until the 2 islands are connected. When the last joint sealed, the hidden underwater highway was ready for traffic to pass beneath the busiest shipping lanes in Asia. Back above the waves, the main bridge stretches for more than 18 miles, supported by towering pylons and sleek cable stays. Every part of it had to balance 2 competing needs. It had to rise high enough for cargo ships to pass below, yet stay aerodynamic enough not to sway or catch wind like a sail during a storm. The entire bridge tunnel system, bridges, tunnel, and connecting roads, was designed to meet one continuous standard for safety, lighting, drainage, and emergency exits, so drivers never feel like they're switching between different structures. To anyone behind the wheel, it feels like one smooth, endless highway floating across the sea. Building something that ambitious doesn't come cheap. The total cost reached about $18.8 billion, covering everything from the main bridge and tunnel to the approach roads linking it to Hong Kong, Zhuhai, and Macau. The human effort was just as massive. At the peak, more than 14,000 workers and about 300 ships were out on the water at once, driving piles, hauling tunnel segments, and lifting bridge sections into place. They worked to the rhythm of the sea, racing ahead when the weather was calm, and securing everything when a typhoon warning appeared. That relentless stop-and-go effort stretched across years, until finally, in October 2018, the bridge opened to traffic. Number 7. Raffles City Chongqing. Raffles City Chongqing doesn't just stand tall, it floats above the skyline like a fleet of ships sailing through the clouds. Perched at the meeting point of 2 mighty rivers, 8 gleaming towers rise from the edge of Chongqing's peninsula, and stretching across 4 of them is something the world had never seen before. A horizontal skyscraper called the Crystal. Nearly 1,000 feet long and sitting about 820 feet above the ground, it's more than just a sky bridge. Inside are gardens, restaurants, a pool, lounges, and an observation deck that lets visitors stroll between towers without ever setting foot on the streets below. From afar, it looks like a futuristic airship hovering above the city, a design that was very intentional. This was no ordinary site to build on. The location sits where the Yangtze and Jialing rivers collide, one of the windiest, steepest, and most crowded areas in the region. Below is constant river traffic and busy roads packed with cars and trams. The architects wanted the development to look like a harbor in the sky, each tower like a mast, the crystal like a ship's hull. 2 of the towers climb to around 1,160 feet, while the other 6 rise to about 820 feet. The crystal stretches across the 4 mid-height towers, while smaller sky bridges connect it to the taller pair, creating a web of walkways high above the city. From the riverbanks, it really does look like an enormous ship anchored in the clouds. Getting it to stand firm in such an exposed location took some of the most advanced engineering China has ever attempted. Each tower's foundation had to resist constant winds, temperature swings, and even the subtle shifting of the riverbanks below. The crystal itself was treated like a separate building, a massive enclosed structure with its own steel skeleton, walls, and safety systems, all linked back into the towers. Its glass and aluminum skin alone required thousands of panels, each one carefully shaped and angled so the surface would look smooth and continuous, whether you were staring up from the street or standing inches from the windows. But the real jaw-dropper was how they built it. The crystal wasn't assembled in one piece. It came together like a puzzle of 9 enormous sections. 4 of them were built right on top of the towers, as if workers were constructing a ship on rooftops. The other 3 were assembled on the ground, each one the size of a small building, then slowly lifted hundreds of feet into the air by custom cranes. Each lift had to be timed with calm weather, since a sudden gust of wind could sway the piece like a pendulum. Once in position, crews guided it with pinpoint accuracy until it locked perfectly into place. At its peak, the site buzzed with more than 6,000 workers. Welders, crane operators, and engineers moved in careful rhythm, working around rain, fog, and unpredictable river winds. The cost was as bold as the design, around $4.8 billion for the full project. That included not only the towers and the crystal, but also a huge mall at the base, office spaces, apartments, a hotel, and all the bridges and walkways that tie it all together. When Raffles City Chongqing opened in late 2019, the city turned out in force. The mall drew crowds by the hundreds of thousands, and the crystal's observation deck became an instant icon, offering a glass floor view over the exact point where the 2 rivers meet. Number 6. Shanghai, Zhongshan, Deepwater Port. Phase 4, Automated Terminal. Out on the open sea, far south of Shanghai, engineers did something that sounds impossible. They built a new coastline and then placed a working port on top of it. The Zhongshan Deepwater Port, Phase 4 terminal, covers about 550 acres of man-made land and stretches along roughly 1.5 miles of waterfront. From the start, it was designed for the biggest cargo ships on Earth, those floating cities that carry thousands of containers stacked like Lego bricks. Trial operations began on December 10, 2017, and from that day forward, the port has been rewriting the rules of global shipping. Before it could move a single container, there had to be land where once there was only water. Construction crews began by strengthening the seabed and piling up rock and sand to form new islands. Huge concrete boxes called caissons were dropped into place and filled to lock the shoreline tight against waves and tides. When the ground was ready, workers laid out the site like an electronic circuit board, burying power cables, data lines, and guiding markers for driverless trucks. Rails for cranes were set into the pavement, and at the center of it all, they built a tall glass control tower that works more like a computer lab than a harbor office. The berths were dredged to about 51 feet deep, giving the largest ships on the planet enough room to dock nose first. Then came the muscle, the machines that make the port move. Along the edge of the sea, 21 giant cranes now stand like red skeletons, each one able to lift a 40-ton container with a single motion. Behind them, 108 automatic stacking cranes take over the storage yards, placing containers in neat, towering rows nearly 80 feet high. And zipping between them are around 125 self-driving carriers, flat, electric vehicles that roll between the cranes and the stacks, carrying containers back and forth 24 hours a day. It looks like a dance of robots moving in perfect rhythm, never stopping for food or rest. But the real magic is the system running the show. Instead of buying foreign software, Shanghai built its own smart control brain. A program that decides exactly where every container goes, when it moves, and which machine should handle it. It constantly updates every few seconds as ships arrive, trucks line up, or a crane slows down. That's why the yard can stay dark at night. No floodlights needed. Sensors, lasers, and algorithms guide every machine quietly and accurately, even in fog or rain. Building this much technology wasn't cheap. The terminal cost about $1.95 billion, but that money created the world's largest fully automated container port. It also helped Shanghai keep its title as the busiest port anywhere on Earth. Number 5. Three Gorges Dam Shiplift. The Three Gorges Dam shiplift is one of the most astonishing machines ever built for a river. It works like a vertical elevator for boats, lifting or lowering them about 371 feet in a single motion. That means a 3,000-ton ship that once had to crawl through 5 separate locks can now make the trip in roughly half an hour. The heart of it is a huge steel box, or chamber, that carries both the ship and a layer of water. This chamber slides between 4 concrete towers built into the left side of the dam. It's about 394 feet long, 59 feet wide, and 11.5 feet deep, big enough for river cruise ships and heavy cargo vessels that travel the Yangtze every day. When it moves, the lift raises or lowers around 37,500 tons in total, counting the water, the structure, and the counterweights. No other ship elevator on Earth handles that kind of load. To build it, engineers had to turn a steep cliff into a giant machine room. They began by cutting deep into the rock and pouring heavy foundations for the 4 main towers. Each tower had to be locked directly into bedrock so it could take the weight and vibration of the moving chamber. As the concrete towers climbed, steel workers built the massive ship chamber in sections at ground level. Each piece was shaped like a stiff metal box and thick enough to stay perfectly straight, even with waves and a boat rolling inside. The pieces were then slid into position inside the towers and welded together so precisely that the seams are nearly invisible. The next step was adding the system that makes the chamber move. Along each tower, workers installed tall racks of steel teeth running vertically, matched with motor-driven pinions that climb up and down those teeth like gears on a rail. Dozens of electric motors drive the system, and huge counterweights hang inside the towers to balance the chamber's mass. That means the motors don't have to lift all the weight themselves, they just guide the motion. Engineers chose this rack and pinion setup because the water levels above and below the dam rise and fall dramatically throughout the year. Traditional cable lifts would have been too risky, but this system can keep running no matter how the river shifts. Before any ship could ride the lift, the team tested everything again and again. They ran the chamber empty to check the gears, lasers, and brakes. Then they filled it with water and slowly practiced full lifts, watching sensors that measured stress on every bolt, beam, and bearing. When the first cargo vessel went up in July 2016, the test worked perfectly. By September 18th that year, the lift officially opened for limited service, instantly cutting what used to be a several-hour process down to minutes. Today, hundreds of ships pass through it each week as if it has always been part of the river itself. The shiplift is part of the much larger Three Gorges project, which cost about $31.8 billion overall. The lift was one of the final and most expensive additions to complete the entire dam system. At the peak of construction, nearly 40,000 workers were stationed across the entire dam complex. Number 4. Beijing Daxing International Airport. From above, Beijing. Daxing International Airport looks like a golden starfish stretching across the plain south of the city. But when you're standing inside, it feels more like an endless flowing room, bright, open, and impossibly smooth. The main terminal alone covers around 7.5 million square feet, making it one of the largest single buildings on Earth. Altogether, the airport spans roughly 18 square miles and sits about 29 miles from central Beijing. It was built to ease the traffic crushing the city's older airport and to merge air, rail, and highway travel into one giant connected hub. The magic lies in the layout. Most airports make you walk through long, tiring corridors, but Daxing is designed to cut that distance to almost nothing. The entire building fans out from a central hall beneath a flowing, ribbed roof that feels alive with daylight. The roof's sweeping steel ribs don't just look elegant, they do the heavy work of carrying huge spans without cluttering the floor with columns. Skylights flood the hall with soft, natural light, and the multi-level plan keeps domestic and international passengers moving separately without confusion. Pulling off something this graceful took construction on a truly wild scale. Work began in late 2014, and in just 5 years, the core of the project was complete. That's almost unbelievable for something this vast. Before a single column could rise, crews spent months strengthening the soft ground beneath the runways and taxiways. Then came the steel. Hundreds of giant pieces hoisted and joined in a choreography that let the roof come together like a massive puzzle. The schedule ran with zero slack. Pour the cores, lift the trusses, close the roof, and start the endless network of baggage systems, wiring, and safety gear hidden below. Everything had to move in perfect rhythm, or the whole plan would fall behind. At its peak, more than 40,000 people worked on the site every day. Steel workers bolted up roof sections as concrete crews shaped the concourses beneath them. Electricians ran miles of cables while other teams installed glass panels, tiles, and lights. Hidden below the surface is one of Daxing's best ideas: a massive ground transportation hub built directly under the terminal. Covering about 860,000 square feet, it connects high-speed rail, metro lines, and regional trains right to the airport's heart. You can land, collect your luggage, head down an escalator, and be on a fast train into the city in minutes. Of course, all this came with a huge price tag. Building the airport itself, runways, terminal, and aviation systems cost around $17 billion. But when you add the expressways, railways, and city infrastructure built to support it, the total climbs to about $63 billion. Number 3. Ping An Finance Center. The Ping An Finance Center isn't just a skyscraper, it's an engineering challenge turned into art. Rising about 1,965 feet over Shenzhen, it's the 5th tallest building in the world, and the tallest in southern China. From the outside, it looks simple, a single, sleek spire tapering into the clouds. But everything about it was designed to fight the problems that come with that height: wind, weight, lightning, and time. 8 giant columns frame the tower, all tied to a thick concrete core at the center. Between them, huge steel trusses act like muscles, connecting the core and the outer frame so the whole building moves as one. That aerodynamic pointed shape isn't just beautiful, it reduces wind pressure by nearly 1/3, which keeps the tower from swaying when typhoons hit the coast. The hardest work started before a single floor went up. The site sits right next to an active subway line, so crews had to dig a deep foundation pit while making sure trains could still run safely beside them. They built thick support walls, drove massive piles into the ground, and poured a reinforced concrete base strong enough to hold the weight of a vertical city. Only after months of underground work could the team start building upward. Once they did, the pace was incredible. Each new floor went up in about 3 or 4 days. Week after week, Shenzhen's skyline changed before people's eyes. The tower's 8 outer columns are shaped like chevrons, and they give away the building's secret. Inside, the central core carries most of the stiffness, while those outer columns handle loads from wind and gravity. 4 sets of steel outriggers, horizontal braces hidden at different levels, tie everything together. It's a little like connecting the hub and rim of a wheel with spokes. That setup allows for wide, open office floors without interior columns getting in the way, a must for big trading desks and tech companies that rent here. Then there's the skin, the part that gives Ping An its bright silver look. Instead of aluminum, the builders used marine-grade stainless steel, about 1,700 metric tons of it. Regular metal would corrode in Shenzhen's salty, humid air, but this alloy stays sharp and shiny for decades. Every panel was custom-made and installed with surgical precision, aligned so that the tower's vertical ribs stay perfectly straight from the ground all the way to the tip. The job site itself was a city within a city. At peak, more than 15,000 workers filled the grounds. Core crews pouring concrete, steel teams bolting the mega columns, welders working on the trusses, facade installers lifting panels hundreds of feet in the air, and electricians wiring the massive podium that connects to the subway. Because Shenzhen gets hammered by lightning, the design had to think ahead. The stainless steel piers double as a lightning cage, safely channeling strikes to the ground. A tower like this doesn't come cheap. The full development, 2 towers, podium, and all, cost about 13.5 billion yuan, roughly $2.1 billion US. Number 2. Shanghai Tower. Shanghai Tower doesn't just rise into the clouds, it seems to twist right through them. Standing about 2,073 feet tall in Shanghai's Pudong district, it's the tallest building in China and one of the tallest on the planet. Completed in late 2014 and opened the next year, it sits beside 2 other icons, the Jinmao Tower and the bottle opener-shaped World Financial Center, forming a skyline trio that looks almost sculpted by the wind itself. That twisting shape isn't just there to impress. Every floor of the tower rotates slightly from the one below it, making a full 120-degree turn from bottom to top. This slow spiral has a powerful purpose: to calm the violent winds that slam into skyscrapers of this height. When engineers tested models in wind tunnels, they found that the curved twist cut wind pressure by about 24%. That aerodynamic advantage meant lighter materials, less sway, and roughly $50 million saved in construction. What's hiding beneath that glass skin is even more fascinating. Shanghai Tower is really two buildings in one. Inside is a tall, straight concrete and steel core that carries the structure. Outside, a transparent curtain wall wraps around it, creating a kind of giant greenhouse that spirals upward. Between the two walls is a calm buffer zone filled with open sky gardens, cafes, and public lounges. The air trapped between the layers helps insulate the interior, keeping temperatures more stable and reducing the energy needed for heating and cooling. These sky atriums also cut noise and give office workers, hotel guests, and visitors a rare treat: green, sunlit spaces hundreds of feet in the air. But before any of that could rise, the builders had to anchor it into the ground. And that meant solving one of Shanghai's biggest challenges: soft river delta soil. To hold up a structure this heavy, engineers poured one of the largest concrete foundations ever done in China, using about 61,000 cubic meters, nearly 80,000 cubic yards, of concrete in a single non-stop pour that lasted more than 2 days. Beneath that slab are over 1,079 piles of reinforced concrete and steel, each driven about 250 feet deep, to reach firm layers below the soft topsoil. That hidden foundation is the quiet muscle keeping the tower steady through typhoons and tremors. Inside, the building is organized like a series of stacked communities. It's divided into zones, each with its own lobby, gardens, and elevators. Offices fill the lower sections, luxury hotels and observation decks rise near the top, and mechanical systems are neatly tucked between. This design shortens elevator trips and makes the huge building easier to navigate. At full capacity, about 16,000 people can live, work, and visit inside the tower at once. A vertical town with restaurants, lounges, and some of the best views in Asia. Even the elevators are record setters. Using a custom Mitsubishi system, they shoot upward at around 46 miles per hour, fast enough to make your ears pop. In just under a minute, passengers can reach observation decks more than 1,800 feet above the streets, where Shanghai spreads out like a glittering map of light. And to make sure no one feels dizzy or seasick on windy days, engineers installed a massive tuned mass damper, a swinging weight of about 1,000 tons, that moves slightly to balance out the building's sway. It's like a hidden pendulum keeping the tower calm when the wind pushes. All this innovation came with a price tag worthy of its scale. The full project cost roughly $2.4 billion, financed mostly by the city itself. Number 1. Shenzhen-Zhongshan Link. It's hard to imagine the Shenzhen-Zhongshan Link until you realize what it really is. A 15-mile chain of bridges, tunnels, and man-made islands stretched across the open sea. It connects two huge cities across the Pearl River Delta, a place once known for hours-long detours and endless traffic. Now cars make the same trip in about 30 minutes. The link opened on June 30th, 2024, and it's already being called one of the boldest construction projects ever built on water. More than 15,000 workers fought through brutal typhoons, extreme heat, and deep-sea mud that behaved like quicksand. It wasn't just a bridge, it was a battle with nature. Divers, welders, crane operators, and engineers worked together around the clock, racing against the weather to make the dream real. The structure itself is built in 3 parts: bridges on each end, a long undersea tunnel in the middle, and 2 artificial islands that connect them. Those islands are like lungs, helping the link breathe. Workers built them by driving huge steel walls into the seabed, pumping out the water and filling the space with layers of rock and sand until new land rose from the waves. These man-made islands hold the tunnel entrances, ventilation shafts, and safety systems that keep the whole highway running smoothly. Then came the most difficult section, the tunnel. It's made from 32 massive concrete pieces, each about 540 feet long, up to 180 feet wide, and about 35 feet tall. Each block weighs around 80,000 tons, about the same as a modern warship. Crews floated the blocks out to sea, guided them into exact position using tugboats and GPS, and slowly sank them into a trench that had been dug into the seabed. Divers worked more than 100 feet underwater, helping align each piece before sealing it to the next with watertight gaskets. When the last joint locked, the tunnel became one continuous 4-lane each-way highway, the longest underwater road of its kind anywhere in the world. Inside the tunnel, everything is smart. Cameras, sensors, and colored lights watch every car and adjust traffic in real time. There are ventilation ducts, escape passages, and even a hidden interchange underneath so cars can change routes without surfacing. Above the water sits the Lingdingyang Bridge, which handles the shipping lanes. Its steel road deck stretches more than 5,400 feet between 2 towers that rise nearly 900 feet tall. The gap beneath it is about 250 feet high, giving even the world's largest container ships and cruise liners plenty of space to pass. Before any steel was set, engineers tested scale models in wind tunnels at hurricane-level speeds of almost 190 miles per hour to make sure the bridge could survive the strongest storms. Once approved, massive cranes lifted each deck piece into place. Welders sealed the joints, and paving crews finished the surface with a special epoxy asphalt made to hold under salt, spray, and heat. The entire thing cost around $6.15 billion and took 7 years to finish. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.